Okay, Algebra 2 students, in this video we will be learning how to solve a brand new type of equation that you've never probably looked at before, and they're called matrix equations. Your heading then obviously for today is called solving matrix equations. Please write that in your notes, lesson 4.4, and I guess you could put part 2 if you want to, because we did spend 2 days on this. The other video, of course, was part 1, and you can call this part 2 if you want to. I hope you're taking really good notes, the type of notes that you could keep one day and take to college with you if you need to. I'm serious about that. I've had students do that in the past, and it's been helpful to them. I hope you're taking notes organized in a notebook in which your notes last, and you are able to use them later. Okay? Solving matrix equations, lesson 4.4, and be sure and include today's date. Now, first, let me start off by using an old Algebra 1 equation type of problem to show you basically what we are going to do with matrix equations. Now watch this. Here it is. You can take notes on this, but you probably don't have to. I would recommend you just watch, but that's up to you. If I have this equation here, obviously you know the answer is 2. Because 2 times 2 is 4. Another way you knew that is you divide both sides by 2, and you get x equals 2. But remember, there's another method called the reciprocal. Is that how you spell that? I hope it is. I think that's right. Reciprocal method, or the inverse method. Okay? And what that means is this. You take your coefficient, which is 2, and you flip it. And then you multiply both sides by the reciprocal. Okay? 1/2 times 2 is 1, so 1x. 4 times 1/2 is 2. Now that's the exact same thing as dividing by 2, to be honest with you. But it's also called the reciprocal or the inverse method. Whoa, wait a second. Did you hear that word? Inverse method. What did we learn how to find yesterday? Do you remember? Inverse what? Do you see what I'm saying? Maybe if we're dealing with matrices, just like we took the inverse of 2 and multiplied it by both sides, maybe with matrices we could find the inverse matrix and multiply it by both sides. Okay, see the connection here? Let me show you another example. And again, you can write this down, but I don't think you have to. If I had 2/3 x equals 12, I could divide both sides by 2/3. Okay, that's fine. But I could also use the inverse or reciprocal method, flip this, which is 3/2, and multiply both sides by what? 3/2. Well, 3/2 times 2/3 would cancel out, leaving you with x. 12 times 3/2 would be 18. Okay? So I'm just trying to show you the reciprocal method is not one that I teach very often or use. I would just rather say, hey, divide both sides by 2/3 and be done with it, okay? Like this. But I wanted to show you kind of the parallel as to why we are going to use inverse matrices today and how they work. Alright? Now, what if we can use that same procedure with matrix equations like I just said a couple seconds ago? We actually can. Remember, we just learned how to find the inverse of a matrix earlier in lesson 4.4. Okay? Let me show you what I mean. I would like you to copy down this matrix equation. Are you ready? Copy this down. No, I never pause the video because I want to move on, okay? Listen, it's always easier for you to pause it than to speed me up if I'm going too fast. So, copy this in your notes. I'm going to move on, pause the video, and copy it down if you need to. Or if you can write it down and listen at the same time, that's fine. Now, here's a matrix equation. First of all, this x being really big and dark like that doesn't mean a hill of beans of nothing, okay? That just happened to be how dark it came up when I took my text and I made it go all the way to like 48, and I hit X, it came up really dark, okay? So it has nothing to do with, with, it doesn't have any significance, it just means X. Now I will say this though, when you're solving a matrix equations like this, you are solving for a matrix. In other words, this big X, you could actually do this if you wanted to, you could put a matrix right here. You're trying to find a matrix so that when you multiply this matrix here, are you listening, times this matrix here, you will get this right here. Got it? That's your goal, okay? So with that in mind, here's what we do. Remember my example I just gave you guys. If you have something like 2x equals 4, you can take this number next to the x and find the inverse of it, which is 1/2, and multiply both sides by the inverse. Well, the same thing applies here. What number was right next to the x? 2. See that? And you found the inverse of 2, right? Well, what matrix is right next to x? This one. So find the inverse of it and then multiply it by both sides. Just watch, take some notes, okay? I'm going to solve this matrix equation. So, excuse me, sorry. So I'm going to find the inverse of this matrix. Remember how to find the inverse of a matrix? Remember, step 1 is to find the determinant. Got it? So multiply up, it's 10. Change the sign. Multiply down, 11. Combine and you get a 1. So the determinant's 1. What do you do next? Remember, these two numbers here, you change their signs. These two numbers here, you swap places. Okay? Now, you take your determinant and you flip it. Well, 1 is the same thing as 1/1. If you flip 1/1, you still get 1. If you take 1 and multiply it through, it doesn't change anything. So there's your inverse matrix. So if you take this and multiply it by both sides, let me do something real quick here. If you take this matrix here, now remember, let's go back up here. Remember, you found the inverse of 2, right? And then you multiplied it by both sides, right? So if I take this matrix here and I multiply it by both sides, first of all, if I multiply the inverse times this matrix, they're basically going to cancel out. Remember, listen guys, when you take an inverse times its matrix, you get out what? That. Okay, that's the identity matrix. To me, for just lack of a better words, that's the same thing as these things here. Just canceling out. Okay, look, when you took the inverse of 2 is 1/2. When you take 1/2 times 2, they cancel out. You're just left with x. So when you find the inverse of this and then multiply it times this side, they cancel out. You're just left with x. Now here's where it gets tricky. And students, guys, ladies, dudes, look, I can only tell you this so many times, you're going to have to get it, okay? You will not get the answer right. You took this inverse right here, right? And you multiplied it by this side. Now you've got to multiply it by this side. So most of you want to pull it right up here and multiply. That's wrong. It will not work unless you first, sorry guys, unless you first pull that matrix over. Wow, that's really weird. Sorry. Unless you first pull that matrix over and put this matrix here. If you do not multiply these two matrices in this order, the inverse matrix first and this matrix second, then you will miss the problem. If you get it right, it'll be a crazy coincidence. You must put the inverse. Now over here, it doesn't matter. I don't care. You're not going to multiply them anyways. You're just going to cancel them out and put an x. But over here, when you're trying to multiply to find out what x equals to get your answer down here, you must put the inverse matrix first. So let's multiply these two matrices together. Got it? We have a 2 by 2 times 2 by 2. Do your inside numbers match? Yes. Your outside numbers are 2 and 2. So you know your answer is going to be a 2 by 2. Do you remember how to multiply matrices? You take this row times this column and then times this column. So 1 times 4, positive 4, negative 5 times 2, negative 10, combine and you get a negative 6. Now take this row times this column. 1 times first, negative 1. Next times next, 0, combine those, negative 1. Now, let's take this row right here. Slide it down here. Now we're going to take this row times this column. First times first, negative 8. Second times second, positive 22. That gives you a 14. This row times this column. First times first, positive 2. Second times second, 0. That gives you a 2. Now, that is the correct answer. I'm checking the book right now. It's right. So here's what you just did. Now in your notes you have all this written down. Okay, so I'm going to do something a little different. I'm going to pull this off to the side. Okay, I'm going to get out my handy dandy eraser and erase all of this. Okay, now you just solved for x, didn't you? Here's the answer. So Mr. Erhard, are you telling me if I take this matrix here and multiply it times x, which is this right here, I should get out this matrix right here. I'm having problems there, aren't I, guys? Oh well. Anyways, are you telling me if I take this matrix times this matrix, I'll get this out here? That's exactly what I'm saying. And watch real quick. Negative 66, positive. Okay, where'd I mess up? This will be funny. That's right, okay. Negative 66, positive 70, that's 4. Negative 11, positive 10, that's negative 1. Now this row times this column. Negative 12, positive 14, 2. Negative 2, positive 2, 0. Booyah, okay? It works. And on a test or a quiz, you can check your answer by putting this back in and making sure you get out this right here. Alright? Let's try one more and the video's over. Short lesson today, guys. Not difficult. Pretty simple. Okay, I've got a matrix equation. Matrix equation. So I want to solve for x. So I take the coefficient of my x right here and I find the inverse matrix. So 1, 0, 2, 2. Step 1, when you're finding an inverse matrix, find the determinant. So multiply up, that's 0. Multiply down, that's 2. Combine and you get 2. So there's my determinant. Next step, you take these two numbers here and change their signs. Now 0, neither positive or negative, doesn't matter. These two numbers here swap places. Now, next step, you take your determinant and you flip it. 2 is 2 over 1, flip it, and you get 1/2. Now multiply it through. 1/2 times 2, 1. 1/2 times negative 2, negative 1. 1/2 times 0, 0. 1/2 times 1, 1. Or a 1/2, excuse me. So there is my inverse matrix right there. Okay? Now, I'm going to take that, and obviously if I take it and multiply it by this matrix here, these two will cancel out like that, and I'm left with x. Now, don't forget, for this matrix here, I have to squeeze, and once again, I'm not sure why I'm having problems with this. Pull this over here. Now don't forget, I've got to take this inverse matrix times this side here. But remember, I have to put the inverse matrix first. And so here we go. There we go. Finally, success. So we're going to squeeze our inverse matrix. Well, not quite far enough, is it? You must put your inverse matrix first, okay? Before you multiply it times this, please don't forget that. So here we go, guys. Let's get after it. We have a 2 by 2 times a 2 by 2. Your inside numbers match your outside numbers are a 2 and a 2. So your order's a 2 by 2. Row times column. First times first is 1. Second times second is positive 2. That's going to give you a 3. Then then row times next column, first times first, negative 5, second times second, positive 6. That gives you a 1 when you combine those. Now we're going to go down to the next row, and we're going to take row times column, 0 times 1, 0, 1 half times negative 2, negative 1, combine, negative 1. Then row times column, 0 times negative 5, 0, 1 half times negative 6, negative 3, combine, negative 3. There's your answer. So, Mr. Error, you're telling me if I take this matrix right here times x, which is this right here, if I did that, if I took this matrix here times this matrix here, I will get out this right here. That is exactly correct. That is exactly what I'm saying. Okay? So, I've not gone too fast through this. I really could have crammed all this into one lesson, but I feel like it was just too much, in my opinion, to comprehend. I really, really did. So here's what I'm saying to you, okay? I'm saying to you, if in place of x, you put this matrix here and multiply these two together, you would get this, okay? Let's see, 3, negative 2 is 1. 1, negative 6 is negative 5. 0, negative 2 is negative 2. 0, negative 6, negative 6. Now I can do these pretty fast, but I just multiplied this times this, and I got this right here. Okay? I hope this video has been a help to you guys. If you have any questions, please don't hesitate to call or email.